everyone. So we are the group 5. So here are the members. Cassie Cavi, Jennifer Fernandez, Renzel Nolasco, Marisol Pilar, Natalie Rinien, Sharamir Sarmiento, and Rachel Ann Valmoha. Now we are going to discuss the number and operation. First is how important is the number and operation in the numeracy development of learners. So, the most important standards for early childhood are the standards for programs. For teaching and for assessment, these should be built on flexible development and guidelines for young children's mathematical learning. Guidelines should be based on available research and expert practice. Focus on and elaborate the big ideas of mathematics and represent a range of expectation for child outcomes that are developed menting appropriate. So, ang pinakamahalagang pamantayan para sa maagang pagkabata ay ang pagpapantay para sa programa. Para sa pagtuturo at para din sa pagtatasa. Ang mga ito ay dapat na binubuo sa nababaluktot na mga patnubay ng mga bata. At ang mga alintuntunin ay dapat na nakabatay pa rin sa magagamit na pananaliksik at kasanayan sa dalubhasa, tumuon sa at ipaliwanag ang mga malalaking ideya ng matematika at kumakatawan sa isang bahay ng mga inaasahang para sa mga resulta ng mga bata at naaangkop sa pag-uunlad nila. Next is the number and operation. So, the number and operation are arguably the most important of this area. Now, the learning of the numbers and operation is the early childhood years. These domains of children numerical concept and operation can be thought of as consisting of two foundational ideas. One is for the number and one is for the operation. So although these are highly interrelated, operation are not limited to the four operation of adding, subtracting, multiplying, and dividing. By operations, we can include here the countings, comparing, grouping, uniting, partitioning, and also composing. So dito, ang number and operation ay masasabi nating pinakamahalaga at ang pag-aaral ng number and operation ay unang taon ng pagkabata. Ang domain ng mga numerical na konsepto at operasyon ng mga bata ay maaaring isipin na binubuo ng dalawang pangunahing ideya. Isa para sa numero at isa para sa operasyon. At bagamat ang mga ito ay lubos na magkakaugnay, ang mga operasyon ay hindi limitado sa 4 lang na operasyon ng pagdaragdag, ng pagbabawas, pagpaparami at paghahati. Sa pamamagitan ng mga operasyon naman ay maaari naman isama ang pagbibilang, paghahambing, pagpapangkat, at pagsama-sama at paghati at pagbubuo. It is crucial that this early knowledge should be supported by the experiences in homes, daycare settings, and pre-kindergarten so that all children build this rich base of numerical experiences and cultural knowledge. So, napakahalaga na maagang kaalaman nito sa mga bata ay dapat masuporta ng mga karanasan ng mga sa tahanan. Isa na dito ang daycare setting at pre-kindergarten upang ang lahat ng mga bata ay bumubuo ng mayamang batayan ng numerical na karanasan at kaalaman sa kultura. So, kailangan talaga na inuuna yung counting, and in that way, madalian lang sila ang mga bata na magbilang. At para mas mahusay pa sila sa countings at math. At kailangan talaga na ng step by step yung pagtuturo natin sa kanila sa math. So kailangan na i-guide natin sila towards their journey and towards the math journey.
Counting. Number knowledge emerged surprisingly early in life and develops considerably during the first 3 years. Infants can already discriminate among and match very small configurations, 1 to 3 of objects. For example, when 6-month-old infants are shown a series of pictures that always depict 3 objects, albeit different types of objects from picture to picture, they gradually lose interest in the pictures. If the configuration of object depicted in the pictures is then changed from 3 to 4, infants notice the change and become interested again. Starkey and Spock and Gell-Mann 1990. So they can see small configurations of objects non-verbally called subdivising. Next one is, by 1 to 8 months of age, infants can notice which of the two collections contains more objects, and that is according to Cooper 1984. This provides an early perceptual basis for number, but it is not yet number knowledge. This illustrates a critical point. Mathematical knowledge initially develops qualitatively. In this instance, children's ability to see small collections grows from perceptual to imagined to numerical patterns, and that is according to Steve 1992. And next one is, perceptual patterns are those the child can and must immediately see or hear, such as domino patterns, finger patterns, or auditory patterns. Later, children develops the ability to visualize or imagine such patterns. Finally, children develop numerical patterns which they can operate on as when they can mentally decompose a 5 pattern into 2 and 3 and then put them back together to make 5 again. These types of patterns may look the same on the surface but are qualitatively different. All can support mathematical growth and thinking, but numerical patterns are the most powerful.
Along comparing and ordering, human beings naturally make perceptual judgment of relative quantities. But children need to learn the cultural methods of matching and counting to find out more dependably which quantity is more. So, sa ating mga adults, kaya na nating i-judge or make a perceptual judgment between things kung sino yung mas madami. But ang sabi dito, children need to learn the cultural methods of matching and counting. So, kailangan pa nilang pag-aralan at pagkumparahin at bilangin yung two different things para malaman kung sino yung mas madami. Next, pre-kindergarteners can learn to use matching to compare collection to create equivalent collection. Many 3-year-olds judge that two collections are equal when the objects in one collection are placed in a spatial proximity to the object in another collection in a one-to-one fashion. So, natututunan daw ng mga pre-kindergarteners to compare and to match and to create equivalent collection. So, many 3-year-olds ay sasabihin daw yung two collection ay magkaparehas pag yung isang bagay sa isang collection ay ma-replace in spatial proximity. So, pag sinabi po kasi nating spatial proximity is yung nearness in space. Next, by age 4, many children use such matching to create collection equal to one that has already been constructed by Piaget and Zeminska. For many 4-year-olds, the number world sequence developed into a kind of mental number list. So, consequently, children determine which pair of collection has more items by counting each collection and then using the mental numbers to determine which number comes later, thus, which collection is. So, malalaman nung bata which pair of collection is more pag binilang daw nila isa-isa yung collection. Then, ginagamit yung number list para malaman kung which number comes later, which collection is larger. So, finding out how many more or less, fewer, there are in one collection than another is more demanding than simply comparing two collections to find out which has more. So, finding out how many more or less fewer ay mas demanding or mas nagre-require ng much more skills and effort. So, rather than simply pagkumparahin yung dalawang collection para malaman which has more. So, next. Children have to understand that the number of elements in the collection with fewer items is contained in the number of items in the collection with more items. That these, they have to mentally construct a part of the larger collection equivalent to the smaller collection that is not visually presented. They have to determine the other part of the larger collection and find out how many elements are there in this leftover. The situational language in comparing situation is complex, and children need considerable experience solving comparing problems and hearing and telling comparing stories. So, sabi po dito, children need considerable experience solving comparing problem. Kasi po, pag nagbigay ka ng comparing situation in a situational language, anong isasagot ng bata or walang alam isagot ng bata kasi he or she doesn't even know what is comparing. So, before ka magbigay ng problem solving of comparing in a situation language, make sure that there is already experience. Kasi mahirap unawain or sagutan ang isang bagay without experience or without any knowledge at all.
Along adding or taking away. Even toddlers notice the effects of increasing or decreasing small collections by one item. For example, 24-month-olds expect that when two objects are put into a covered box and then one ball is removed from the box, that one ball remains in the box. Likewise, when two balls are put into a box and then another ball is put into the box, most expect that the box then contains 3 balls. Pre-kindergarten children become more proficient in reasoning about the effects of increasing or decreasing the items of two collections of objects. When two collections are created simultaneously by placing items one for one in separate locations, many pre-kindergartens correctly judge that the items in the two collections are equal even though they do not know exactly how many objects are in the collections. If items of one collection are then increased or decreased, children as young as age 3 correctly judge that the collection added to contain more or the collection subtracted from the contains fewer than collection that was not changed. However, problems involving two collections that are initially unequal present a difficulty for 3-year-olds. For example, if two collections initially differ by 2 objects and one object is added to the smaller collection, many 3-year-olds will incorrectly say that the collection to which the object was added has more. In contrast, some 5-year-olds know that this collection still has fewer. They know that both the addition and the initial inequality must be taken into action in reasoning about the effect of the addition on the collections. Problems such as 6 and 2 more can be solved by children as soon as they can accurately count. Sa madaling salita, ang mga problemang kinasasangkutan ng dalawang koleksyon na sa una ay hindi pantay ay nagdudulot ng kahirapan para sa mga 3 taong gulang. Habang ang mga 5 taong gulang ay alam nila na ang pagdaragdag at ang paunang hindi pagkakapantay-pantay ay dapat isaalang-alang sa pangangatwiran tungkol sa epekto ng karagdagan sa mga koleksyon. Children who cannot yet count on often follow 3 steps: counting objects for the initial collection of 6 items, counting 2 more items, and then counting the items of the 2 collections together. These children naturally use such counting methods to solve story situations as long as they understand the language in the story. Research and expert practice indicate that children develop and eventually abbreviate the solution methods. For example, When items are hidden from view, children may put up fingers sequentially while saying 1, 2, 3, 4, 5, 6, and then continue on, putting up 2 more fingers, 7, 8, 8. Children continue developing and abbreviate their counting methods even further. Rather than putting up fingers sequentially to count the 6 hidden items, children who can count on simply say SIX 7, 8, 8. Such counting on is a landmark in children's numerical development. It is not a rote step. It requires conceptually embedding the 6 inside the total.
Along composing and decomposing. Composing and decomposing are combining and separating operations that allow children to build concepts of parts and wholes. Most pre-kindergartners can see that 2 items and 1 item make 3 items. Even 3 years old can solve problems such as 1 and 1 more non-verbally, creating a matching collection. Although this ability is limited to very small numbers, later, children learn to separate a group into parts in various ways and then to count to produce all of the number partners of a given number. For example, 8 as 7 plus 1, 6 plus 2, 5 plus 3, and so on. Children can develop sophisticated composing and decomposing operations by bringing together 2 aspects of the early numerical mind: seeing numbers, visualizing little numbers inside bigger numbers, including seeing 3 as 1 and 1 and 1, and counting. Children can come to see all of the different number partners for a given number by working with objects. Example, 6 objects within a story context. Example, animals in 2 different pens. Children can separate the 6 objects into the different partners that make 6. Example, 5 and 1, 4 and 2, 3 and 3 are all 6 partners. Children are fascinated with big numbers and elaborating their counting strategies to find sums and differences of 2-digit numbers enhance this fascination. Counting by 2 enhance the children's sense of numerical competence.
Along grouping and place value. Grouping is the operation or process of combining objects into sets having the same number of objects. For example, we can group by trees and describe, say, a set of 18 as group of 3. The big idea of grouping involved making larger unit. In case of example, the new unit is made of 3 objects. Grouping leads to escape, counting, and multiplication, and to later understanding of measuring different units. A special grouping organized collection into group of 10. That is, a numerical collection can be measured using units of 1, tens, hundred, and thousand. And in a written multi-digit numeral, the value of digit depends on the position in the numeral because different digits position indicates different units. Dito, sinasabi na ang value ay yung worth ng isang digit, which is nakadepende sa kanyang position. For example, is yung 18. Ang place value ng 1 ay mapupunta sa tens, and the 8 naman ay mapupunta sa ones. The pattern in the number word are complex and do not help children focus on 10. 11 rather than 10 and 1. 13 rather than 13 or 10 and 3. 20 rather than 2t or 2 tens. 50 rather than 50. Note that other language such as Chinese is in which 13 is read as 10 and 3 are more than helpful. Rather, they must the overall pattern, also neither tin or t say 10 although they mean 10.
Next, along equal partitioning. So the partitioning is the operation of decomposing a set of object into set of the equal size. The simplest form of this big idea is readily understandable by the children, and it emerged around 3 years of age when pre-kindergarten become able to share a small collection of objects equally between two toy animals. So, dito sa partitioning and operation and decomposing a set of object, dito nila makikita yung equal size and the simplest of this form of big idea. Dito nila nakikita yung, dito nila na-understandable ng ang pag i-emerge of this 3 years age lang ay sa pre-kindergarten ay nag-i-able silang nagko-collect through their objects equally between the objects.
So, the idea of foundational for all kinds of multiplication situation and of measurement division, where you know the number in a group, and of partition division, where you know the number of groups. But complexities of finding exact solution with larger numbers, except by trial and error, and of reflecting on a series of repeated action, make this a big best pursued in detail at older grades.
Notes on multi-digit computation. The ideas and skills involved in multi-digit computations are supported by most of the big ideas of numbers and operations. Unfortunately, given present-day instruction, many children think of multi-digit numbers only as single-digit numbers sitting side by side, ignoring their place value, which invites different kinds of errors. Next, to develop computational methods that they understand. Children require strong experiences in kindergarten for earlier. Hearing the pattern of repeating tens in the number words and relating them to quantities group in tens and seeing teen numbers and two-digit numbers as embedded numbers. 52 is 50 and 2. Next, first graders can use quantities group in tens or make drawings of tens. One to do two-digit addition with regrouping and discuss how recording numerically their new tens. Example, 48 plus 26 makes 6 tens from 40 and 20, and 1 10 and 4 from 8 plus 6. So there is a total of 7 tens and 4 for 74. Next, children invent and learn from each other many effective methods from adding such numbers and many ways to record their methods. Second graders can go on to add three-digit numbers by thinking of the group of hundreds, tens, and ones in bold. And they can subtract, example, 82 minus 59 by thinking of breaking apart 82 into 59 and another numbers.